Hello everyone, welcome back to Study. Hope you are all doing very good. Today in this video we are going to study about Prentice's rule. The Prentice's rule is very important to consider in the optometry when you are dispensing a glasses for the patient, right? But before moving to the Prentice's rule, we should know what is prism diopter, which is an important parameter in the optometry. So this prism diopter is the unit of prism. We all know that we use prisms in optometry field very frequently in different type of test and for different or at many purposes. So the prism's unit is the prism diopter, and so the prism's unit is prism diopter, and we denote it with this triangular shape. So you have seen a lot of people writing like this. So this is also what we say is a prism diopters, and you all know that while we are discussing the corneal Hirschberg test, we discussed that 1 millimeter deviation equals to 7 degree and 1 degree equals to 2 prism diopters. So which is actually how you are going to align from by which power of prism you are going to align the eyes. So it is very important to align the eyes with the help of the prism. So prism play a very important role, right? So while we are discussing about the prism diopter, we should know that what is prism diopter, right? So prism diopter is actually, we can say that we are describing it as 1 centimeter per 100 centimeter. The 100 centimeter term can be used as 1 meter, right? So we can say it as, okay, so we can say the 100 centimeter can be termed as the 1 meter. We all know that 1 meter is equals to the 100 centimeters. So one prism diopter, if we have a prism diopter, if we have a prism who is having a power of 1 diopter, right? So one prism diopter. If we have a prism, and its power is 1 prism diopter. So it will actually be, what is the purpose of the prism? So if I'm gonna tell you, it's a prism which we use, and actually the prisms are in circular position. One is the thickest part and one is the thinnest part. So in prism what happens that the light rays, the straight light comes, and when it strikes to the prism it deviates, right? You can see over here it is actually deviating. So what happened that this light, or if I am going to show you more accurately or efficiently, so okay, so now this deviation, right? So when a light was falling straight but it deviated this way, this is a function of the prism, or it's the use of the prism, that it deviates the light. So if we have a prism of 1 prism diopter, right, it is having a power of 1 prism diopter. So how much of deviation it will do? It will deviate the image which is at 1 meter distance. So imagine that a distance between it's suppose this is an object, right, and this is a prism placed between, and this is you. So I'm going to draw it again, so for your ease you can understand what I want to say. So now this is a prism, and you want to focus something which is an object over here, and you are focusing that object from here. You have placed, you are here and you want to see this object. So what you do, you place a prism over here. Now what will happen that this prism, the light rays moving from this object will deviate, will show you a deviation. How much deviation? Suppose this object was at the distance of 1 meter, right? So when the object is at the distance of 1 meter, it will displace, or the person who is viewing through the prism will see a displaced image of about 1 centimeter, right? So when a patient, or when a person observes anything from the prism and the distance between the target or the object he want to see, object of regard, is at the distance of 1 meter, and he is viewing through the prism, what will happen that the person will see the deviated image, and that deviation will be up to the 1 centimeter. So what will happen that image will deviate from its original position and will move to 1 centimeter from that surface, right? Object on a flat surface, be 1 meter away from the prism. So if the distance between prism and the object of regard or the target you want to observe is 1 meter, and you view it from that prism, you will see the image is slightly displaced or a bit tilted in an easiest way. So what we all know that this was a function of a prism to displace the image, right? In normal diagrams you have seen, I will add the picture that how prism deviates or deviates the light or displaces the light. So you can see that we all know that this happens, but when you are viewing anything from the prism, what will happen that the image will be displaced. You will see a tilted image, and the image was actually in front of you, but while you are viewing from a prism and the distance between the prism and the object is 1 meter, the object will be seen slightly tilted position or slightly deviated. So this is a prism diopter, which is a unit of the prism. So now here you can see a clear diagram. If this is a prism, and suppose a person is over here standing and he wants to see this object, right? Here's a target. So if someone wants to see this object through the prism, what will happen that and the distance, if the distance between the prism and the object is 100 centimeter or the 1 meter, how much displacement will be occur? The image will be displaced up to 1 centimeter. So 1 centimeter deviation will be there when there is an object, when the object is 100 centimeter away from the prism. So this person will see the image here, not here. When he will view the image from the prism, the image will be here, right? So this is what we want to say or explain in this phenomena. So now Prentice's rule is very important for you to understand in order to know the decentration concept in the glasses. Okay, so let's see. So in Prentice's rule, what happens? The prism diopter is equal to the power of lens in diopters. Times means multiplying. You are multiplying the factor. The amount of decentration in centimeters. Up now, when the Prentice's rule will be applied. So I'm going to tell you here in this example. And before moving in this example, we are going to discuss something, which is that when you make some glasses, right? So this is the optical center. Suppose this is the optical center of the glasses. So this optical center is when not aligned, or this optical center is not in the center, so is displaced suppose here or here. So what will happen? The displacement will cause the decentration. So this is the glasses. It is the now optical center, but it should be over here, and now but it is here, right? So what will happen? There is some decentration. You can see the decentration between the 2 points, from this point to this point. So this decentration, this was optical center, but the some other center, optical center is not in the center but is displaced either right or left. So this will cause the decentration of the glasses. So when you are making glasses, it is very important to know the decentration should not be there, as it can induce the prisms in the glasses, right? So if there is a prism in the glasses, patient will feel distortions, he can feel color halos, and he will face headache problems, and there are several more problems while he is facing. So while dispensing, it is very important for you to understand that you should not make the glasses inappropriate, or you should align the optical center in the center of the glasses. As we all know that the optical center should be aligned with the visual axis of a patient, so or the optical center of the eye. So when the optical center and visual axis are aligned, patient will see very accurately from the center of the lens. But when the optical center is misaligned or displaced either right, left, up or down, there will be prism induced, and at that case, when there is a prism induced in the glasses, there is applied a rule which is the Prentice's rule. So what Prentice's rule says is that how much prism is induced in your glasses, that prism unit will be prism diopter, which will be equal to the power of lens in diopter. So it will actually be based on the, so the prism which you have applied in the glasses, or the prism which you have introduced in the glasses due to the decentration of the lens, of the optical center of the lens, will be equal to the power of the lens. So it depends on the power of the lens, the power you have, the power which you were going to add in the glasses, with multiplying it with the amount of decentration in the centimeter. So this is an important thing, that decentration should be in centimeters, and you have to multiply that power with the decentration. Decentration means you are going to calculate or measure that how much decentration is over there. So it is applied when the lens acts as a prism. So when does the lens act as a prism? When there is any decentration in the glasses. And prism diopter, so this is a formula that prism diopter is equal to decentration multiplied by the power of the lens. So here it's the symbol that prism diopter equals to C is the decentration in centimeters, and F equals to the power of the lens. So now let's see with the example. So example states that this is all the same. H is the decentration, and D is the power in diopters. So if we have a lens of +5 and there is no decentration, you can see over here the lens is optical center is aligned. You can see here if I'm going to zoom it, so you can see the center of the, okay, let's see. So you can see over here that center of the lens is aligned with the visual axis of the patient's eye. Suppose here is a eye, right? So you can see it's aligned. There is no decentration. So this means that decentration, or H, or it can be either C in centimeters, is 0, and the power of the lens is +5. So how we have said that decentration, how we can calculate the decentration? It was we are going to multiply the C with the F. So F was the power of the lens. So let's see here. If we have the power is 5, and we are multiplying it with the decentration in centimeters, 5 equals multiplied by 0, it will give us the 0 prism diopters. So in this way you can measure or evaluate the amount of prisms in the patient's glasses which you have introduced with the help of the Prentice's rule. So let's see. With the help of the Prentice's rule, what you can evaluate, you can measure that how much decentration has caused the prism, or has introduced the prism unwantedly or unintentionally in the patient's eye. This can also be in those cases when you intentionally want to introduce the prism. So you need to measure that how many decentration will give you how much prism diopter power. So this is all about Prentice's rule. In case of any query, you can comment in comment section. Thank you so much.